We're back live. Just plug in this watch and then we'll get to what we're doing. Okay, whatever. I think this is just going to be like a chill and debug kind of a vibe right now. Get the dev branch working. Hey, Bet. Weird. Yeah, this data looks fine. So what's exactly wrong with this thing? This seems fine to me. Is this supposed to be minus? That seems very wrong. Oh, it is. Backwards. Yeah, so that's still slow. I think I know. Saw the big merge. Yellow's interesting. You do any preliminary testing? Yeah, it seemed like it helped a little bit with breakout. I'm not super set on it, but that, cosine annealing, muon, there's a whole bunch of stuff in there. I'm just working on like making it all actually function together because I had to merge that with like a dev branch that had advanced a little bit. I also made a threading-based vectorization backend, but that's not really going to be useful until Python 3.14. And that's assuming that they actually get it right in 3.14. So yeah. And what the heck is screwing this up so badly? Crazy. We don't have like stupid hyperparameters, do we? No. Testing heavy ball? Yeah, I have Muon in place. Muon seems chill. I mean, it seems like it can't really hurt, and it doesn't really add any perp overhead over atom, so it's worth running. Like, I'm making it so you can just sweep everything. So that's what we're gonna do. You know, you would think that this would be the detach or something, but I don't know what the heck it is making this so slow. I'm working on it, but this is like a massive thing. I don't know what the heck I've screwed up in this merge that's making everything slow either. Well, I mean, this is more that they got desynced, right? So I did stuff that people asked for on dev, and I had this other branch where I was doing all this JE hacking. It's really the merge. This doesn't get used anyways. Not the optimizer. It's all in learn. Somehow. It'd be nice to know what the heck it is. How much do you eat? I don't know. More than I'd like, less than I should. Usually twice. Like 8 or 9. I get good sleep. I mean, what is this? You gotta take me out to dinner or something first. Ah, what the heck did I screw up here, man? That's ridiculous. Think on this. Like, you're not using the wrong LSTM, right? It's just literally a bad merge that did this. You have recurrent cell, right? Self.recurrent. It's called on this. Decode actions. Gives you logics and values. Code observation gives you hidden. And this all looks correct to me. Share messaging me. I'm trying to think of like stuff I've ended up screwing up like this before. Okay, that's annoying. Maybe it's in the losses somewhere. No, I don't see redundant losses. I don't see redundant losses. Is this indented too far? Should be aligned with this, right? And it is. Is the loss not a scalar? No, loss is a scalar. Man. Maybe I can just see the, maybe I can see the diff. This file doesn't matter. You got this diff. You did up the batch size. Doesn't matter. Policy. Same size. CUDA. Your encoder. Got your decoder. Done. Let's test. So I guess it's in clean PufferLib somewhere. Not seeing anything yet. Effect and receive. Well, our eval should be the same. What about our training? Turns is B returns. If LSTMH is none. Forward train. Unpack these. Yeah. Something's gotta be getting broadcasted or something stupid, right? I don't know what else it could possibly be. Like some stupid thing's getting broadcasted. Like I just don't know how else it would work. Oh wait, you know what? Where is it? Found it, you bastard. Yeah, there you go. PyTorch is stupid, guys. PyTorch is really stupid. If you just if you forget to compress a dimension, it'll just broadcast, and then you're doing some crazy operation that doesn't even make sense. Okay, so that's back to training, at least. We have a million things to make work, but this is the base. "60-second solves are pretty cool. Ah, there we go. That's a funny workaround. Okay, that's AMP working. Ugh. this? Yeah, this in forward train. It's gonna feel so nice when this branch is just cleaned up. It's not gonna finish today though. It's too much work. I'm gonna try to get it all to run, but it's not gonna be pretty. Okay, that works. Oh yeah, these don't get flattened, right? Yeah, it's this. Yeah, this is why I screwed it up, because it has to go like that. There you go. So that's P3O working. Yep. E3B. Ah. You have NVIDs. The heck? Oh, I see. Okay, there's E3B running. Just missing. Diversity is all you need. Yay. No attribute. Okay, this is just because you need to pass some args. Oops. The heck, what's wrong with this? Oh, dummy. Perhaps you forgot a comma. It says state. Do you not store state? Do this. The heck? Really? Oh, I see. Yeah, you need this batch. I think you got rid of the batching logic for no reason here. No attribute hidden. Really? Compiling stuff. Okay, this one runs too. The only thing I haven't fixed is myopia. That one's a little harder. I think the priority is just getting a sweep going, though. That should be the priority. Yeah. Sweep this. Okay, that seems good to me. It's on false. Breakouts on a good sweep schedule. Anything stupid set. Oh, policy hidden size. Yeah. Yeah, this works. Well. Okay, that's like mostly stable-ish. I mean, it has all the fixes in it and they run. Let's see what we have on our sweeps. Oh, our variable horizon actually did pretty well. Got 93 at the end. 93 versus 88, really? I think that's pretty damn good. Okay. Our algorithm is actually starting to do stuff. That's nice to know. I know I installed Muon. I think that's imported still. Cool. I know what that is. Oh, one thing I realized? I have to fix the start time. Yeah, I gotta fix the start time. Let's see if that fixes the profile, just moving it to there. It doesn't. Yeah. That's a problem. Okay, well then what we'll do is we'll do two separate runs. Okay, so this should start immediately now, right? Yeah, this starts immediately. So this is what we'll do. This one will not sweep the policy. So this sweep will be called muon. This other sweep is going to be Adam. So that we don't have the compile overhead. So this is now Adam. And it sweeps everything. Good. Cool, that is two sweeps up and running. Right? That's 2 sweeps up and running. Ridiculously fast as well. Can we just take a moment to appreciate that these are probably going to run somewhere in the realm of like, I don't know, just shy of 10 billion steps an hour total worth of sweeps with a grand total of 2 GPUs. That's pretty solid. Promote your work, guys, so people use it. Check this out, it's a decent little repo. Haven't had any major issues so far. Okay, so that's those are our sweeps. Let me just make sure they're actually running. We'll see if we get anything cool out of these. I mean, I think we should at least get a little bit of a performance bump just because we've also made stuff faster in the process. So I mean, this isn't going to be apples to apples, but I think Muon's probably a good idea. And you know, this is probably a good idea. So I think we should be good with both of these. Anybody yammering at me in dev over stuff I broke? Why do I think I misspelled empirical? I didn't. Just tired. Cool. Nice. Removed, update grid cell code was what was unstable. Fixed entities. Yeah, so the suggestion I gave him worked for that. Good. Anybody have anything else that they want looked at the moment? I'm just going through contributor stuff here. This is nice that Bet did this. Just having like our own fast version of Cartpole that doesn't have other dependencies as like a test dem. This is really nice. Good job, Bet. If you're new to RL, even something like this, like a simple like classic env, no dependencies, fast, you know, simple code like this one is actually very useful. You know, we can always run these to like test if new things are broken. You can get them to train in like 5 seconds. Stuff like this is nice. And then obviously at the high end you have stuff like this, which is like a 7,000 some odd line PR. Merge, this is good. Okay. I think we have everything set. So I guess maybe let's just, I'll go through some of my thoughts and my plans for all of this stuff. The purpose of what I was doing today, and there are 10 hours of VODs from today, from all the stuff I was doing. But the main goal of what I wanted to do today is to just like go through all the stuff that is commonly used in the rest of AI that's been popularized over the last several years that RL has just not really picked up on. So, we got cosine annealing, we got the new optimizer, we messed a little bit with mu-p, several other tricks in there as well. Gelus. The goal was just to like modernize a little bit, right? And make sure we weren't missing out on anything obvious. I think we found some stuff that will probably give us, a few small improvements here and there. Muon will probably be good. Maybe the activations matter, maybe they don't, we'll see. We still haven't done architecture work for the main reason being just that it's a little tricky in RL because you want the networks to run so fast. Data is really king. A lot of these problems, at least the test problems, are pretty simple. So like when you start slowing the network down, you really don't do yourself any favors. And the main thing is you just need to get lots of small batches of data through the optimizer. But we'll do that stuff more when we get onto more complex M's. So the hope is that with all these different methods, we're going to be able to run a bunch of experiments. We're going to be able to confirm which of these actually matter, which of these don't. Hopefully we get to delete a few of these. If E3B doesn't work, we'll get rid of it. I think it might work. Diversity is all you need. We'll see whether it is in fact all you need. We'll either get rid of it or keep it and integrate it properly or something like that, right? And there are a few other sort of methods around that are a little larger, but I think this covered most of the nuts and bolts that I wanted to deal with today. And hopefully it should get us a little bit of a faster training speed run, if you will, on Breakout. So going forward, there's still the big advantage estimation algorithm that I've been working on. That's still not fully done. I don't think that's going to be fully done until we start running benchmarks on some harder M's. So maybe we'll do that next, try to get some harder M's in as benchmarks and start trying to like really get these methods working on those as well. But I think that generally we're in a pretty good spot for the next update. I want the next update to be, here's a collection of stuff we've done to improve training and algorithm side stuff in PufferLib. You can get really, really fast training results on a bunch of different M's. Stuff is more stable, all of that. I still don't know what I'm going to do about mu-p because it doesn't work with muon out of the box. I might have to make some adjustments there so that it does, because that could be useful. It's going to depend, right? It's going to depend. But anyways, I think that's going to be about it for today. I'm going to just go answer a few messages. Send some people some notifications that, hey, we're working on all this stuff. And then tomorrow, I'll probably be on streaming a bit in the afternoon. I usually go for a somewhat longer run in the mornings on Sundays. But yeah, I'm probably going to be doing just like some environment bindings and maybe tweaking some experiments, right? Getting the results of these experiments that we've run, and yeah, going from there. So for folks watching, all of my stuff is on puffer.ai. If you're interested in the project, you can check out our demos right here. Star the GitHub to help us out. That really helps us. If you want to get involved with development or just have some questions that you want answered by the community or myself, discord.gg/puffer. And if you're looking for more RL content, we've got a blog here with a really nice quick start guide and a few more cutting edge things as well. And for more, you can follow me on X, where there's some articles that you can't find anywhere else. All RL content. Thanks, and I will see you tomorrow. Enjoy your